Hmm? Cartoon Guide to Chemistry. Alright, let's go ahead and flex some muscles with brain power. Okay, chemistry itself is an awesome subject, and today we're gonna go ahead on the last leg of this series. Now, I'm not gonna show you stuff in this book, so sorry. Go read the book yourself. It's awesome. And here we go. Chapter 10 and Chapter 11, Chapter 12: Chemical Thermodynamics, Electrochemistry, and Organic Chemistry. This will be related to biology, by the way. So heads up if you hate, but you can skip this video if you hate waiting. But you can't skip this video. You have to learn organic chemistry, even if you hate waiting. Ow! I got a paper cut. Ouch. That's why I don't do what I do. I'll do it, but you can't. All right, back to chemistry. Now, chemistry goes ahead, and we have to talk a lot about chemical thermodynamics. You might know the 3 laws of thermodynamics. It's not necessary to learn all of them. You might only need to know just the third one. But yeah, they're all interesting too. Chemical thermodynamics is basically something entirely different. It's about how life seems to work out and how the chemical life seems to work out too. The thing is, chemistry itself is an interesting and beautiful subject. It's just that people and textbooks make it very, very boring. Now, electrochemistry is a different chemistry itself. It's about electricity and chemistry, and it even includes electromagnetism too. Even that sounds cool to me. And electrochemistry is like all those things you do to like electrolysis to separate or like precious metals from ores you find in the earth to make copper, tin, to create bronze, and then you also use that to create iron, and then using all that to be able to, I don't know, let's say mine some oil, coal, all those kind of things. And chemical tech and those chemistry things, they're all good. Electrochemistry goes ahead and shows what we can do with using chemistry to go ahead and do our own stuff. With electricity, of course. And then we have to talk about organic chemistry. This is my least favorite part of chemistry, but it is the most important part of chemistry too, because it's the one that includes us. Not just dead stars and the past, us. Us particularly too. And if you're using organic chemistry, then you're going to need a little bit of biology. Biology itself includes DNA, and it's all created with chemistry, chemical elements, and using those chemical elements, you can literally create anything in your world, your little imaginative world, for example. But the thing is, organic chemistry has its bad things. In fact, it doesn't really explain the Big Bang much, but hey, you don't need chemistry to explain that. You need physics. But back to chemistry. Organic chemistry is the chemistry that teaches us about how carbon dating works and how radio dating works and how you can create life with organic chemistry and how plants and photosynthesis works. Also, that's more in biology's field. It does include a lot of chemistry too, which is why all 3 branches of science, biology, chemistry, and physics, they all need each other to create observations, and also lots and lots of math. Sorry, but no math in this video. Yay! That happens. Without this kind of chemistry, nothing would actually exist. Electricity goes ahead and flows through currents, sure, but how does that work? Sure, you might need physics to explain the actual workings of electricity, but you need electricity to go ahead and do some chemical experiments. In fact, cathodes, anodes, and all those and those batteries things that we learned in the physics series in this channel is actually all actually came from the fact that, hey, you know what we kind of need chemistry here too. If it works out with chemistry, that solution that we use to create the little paste inside batteries and dry cells nowadays, and the original voltage batteries that were used with liquids, cathodes, and anodes, those actually include chemistry because it includes some sort of solution inside the liquid. And the cathodes and anodes themselves, when electricity runs through them, sure, they have like charges and everything, but they also kind of need elements to make them running, and their whole point of those elements is to separate some elements. Like, we're looking for iron, then we just go ahead and take the elements from the cathode or the anode that contains the iron or the copper or the tin. Luckily, those are all elements, so yay! Then we can combine those into an alloy to create bronzes. Then we would probably just use all of them to go ahead and create iron. And the Iron Age can defeat the Bronze Age. Ha 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 ha. And the Diamond Age can defeat the Iron Age. Mwah, ha, 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 ha. And the Netherite Age can defeat the Diamond Age. Slightly. Mwah, ha, 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 ha. Also, sometimes Diamond is better. It looks better. And that's pretty much it. Other than the fact that I cut my finger today in this video. I hope you guys enjoyed this episode. And please do not cut your fingers. It is really painful when you have to put a piece... When you have to... Oh my gosh, that's a lot of blood. When you have to like put a piece of paper on top of it. Just so you can stop it from bleeding and stop it from bleeding. And that's it. I hope you guys enjoyed this video. And I hope you enjoyed seeing me bleed biological stuff. And until next time. Shine out. Peace. Yeesh. Thank you for watching. Why are you still here? Go home. Go home. Bye.